Chlorpyrifos, invented by Dow Chemical in 1965 as a household pesticide. It efficiently disrupted the nervous system of insects, leading to their demise. It quickly rose to be one of the most widely used pesticides, used on agricultural products like corn, soybeans, apples, alfalfa, and much more. It was also utilized for non-agricultural purposes like flea and tick control on dogs and cats and pest control on golf courses. Chlorpyrifos can enter the body through ingestion, skin absorption, or inhalation. A study showed that chlorpyrifos has a 70 to 99% absorption rate in humans and rats. Because of this high absorption rate, it was often found in fat tissue. It also was found attached to blood proteins and even in breast milk. Tests on rats have shown chlorpyrifos crossing from pregnant rats to its offspring. Rates and results of chlorpyrifos are measured by enzyme activity changes. Inside the body, the liver breaks down chlorpyrifos into chlorpyrifos auxin, a potent chemical that can be further broken down into substances like TCP and DETP. The body primarily eliminates chlorpyrifos through urine. About 70% is excreted within a 5-day period. However, the rest can remain in the body's nervous system for a longer duration as it binds to enzymes, which in turn affect nervous cell functions. The effects of chlorpyrifos. Between 1992 and 2017, a total of 1,760 reports associated with chlorpyrifos exposure were documented, with the majority being related to agricultural and occupational settings. Additionally, there were cases involving residential exposure and suicide attempts. Most illnesses resulted from pesticide drift, primarily through inhalation and dermal contact, though instances of exposure through pesticide residue, ingestion, and improper storage leading to a child access were also reported. Bystanders accounted for over 80% of the reported illnesses. Residential cases from non-agricultural use occurred before the ban on household products. Half of these agricultural cases between 2014 and 2017 were due to off-site movement, including spray drift. Clinical signs of chlorpyrifos exposure encompass various symptoms such as eye, nose, throat, irritation, dizziness, nausea, headache, and more. Accidental exposure or intentional ingestion of chlorpyrifos has resulted in death, often with unknown exposure levels or durations, often from pesticide residue or contaminated drinking water are the cause of these results. Fatalities are typically attributed to respiratory and cardiovascular failure. Non-lethal acute poisonings affect the nervous system as well as the cardiovascular respiratory system. In 1996, the Food Quality Protection Act established a stricter safety standard, particularly aimed at safeguarding children. After conducting risk assessments for the re-registration of chlorpyrifos, the EPA recognized the necessity to adjust specific uses of chlorpyrifos to comply with the updated safety standard and to address health and environmental risks associated with chlorpyrifos exposure. Subsequently, in 2000, the registrants of chlorpyrifos voluntarily entered into the agreement with the EPA to eliminate, phase out, and modify certain uses of the pesticide. In 2002, EPA made a number of changes to the required safety measures that improve safety for the environment and for those applying this pesticide, including use of buffer zones to protect water quality, fish, and wildlife, reductions in application rates per season on a variety of crops, including citrus and corn, and an increase in the amount of personal protective equipment to mitigate risk to agricultural workers. In 2012, the EPA significantly lowered the aerial pesticide application rates and created no-spray buffer zones for ground air blast and aerial application methods around public spaces, including schools, homes, and other sensitive areas, to be protective of children and other bystanders, which could potentially be exposed to the inhalation of chlorpyrifos. Between the years of 2014 to 2020, Chlorpyrifos underwent several human health and risk assessments. It was found that there were still unresolved issues related to neurodevelopmental effects. The EPA found that drinking water and food residue exposures significantly contributed to these risks. In August of 2021, the EPA released the final tolerance rule for chlorpyrifos, which revokes all tolerances for chlorpyrifos. So, the chemical and pesticide chlorpyrifos is no longer used today.